It is my pleasure to open this keynote session of this Thursday afternoon. And we have the pleasure today to welcome Dr. Pentland from MIT. Alex Pentland directs the MIT's Human Dynamics Laboratory at the MIT Media Lab. He advises the World Economic Forum, NASA Motor Corporation, and a variety of startup firms. He has previously helped create and direct the MIT Media Lab, the Media Lab Asia laboratories at the Indian Institute of Technology, and Strong Hospital Center for Future Health. Profiles of Sandy have appeared in many publications, including the New York Times, Forbes, and the Harvard Business Review. Sandy is among the most cited computational scientists in the world and a pioneer in computational social science, organizational engineering, mobile computing, image understanding, and modern biometrics. His research has been featured in Nature, Science, the World Economic Forum, and Harvard Business Review, as well as being the focus of TV features, including Nova and the Scientific American Frontiers. His most recent book is Honest Signals, published by MIT Press. Sandy's research group and entrepreneurship program have spun off 26 companies to date, 3 of which are publicly listed, and several that serve millions of poor in Africa and South Asia. Recent spin-offs have been featured in publications such as The Economist and The New York Times, as well as winning a variety of prizes from international development organizations. A few of his interesting experiences include dining with the British royalty and the President of India, staging at fashion shows in Paris, Tokyo, and New York, and developing a method for counting beavers from space. Today, Sandy's presentation is entitled The Third Ring of Health. Dr. Pentland, I'd like to welcome you on stage, and we are looking forward to a very exciting talk.
Hi there. Happy to be here today. Let's see if we can make the computer work. And thank you for inviting me. So what I want to talk about today is a topic that will probably be irritating to many of you, but is a consensus view of, I would say, a sizable, still minority of the CEOs in IT, health, and insurance areas. Now, it's not one level down from CEOs, but there's a sort of growing realization that we need to re-engineer our healthcare system in a particular way that mirrors actually some of the healthcare systems you see in developing countries. And let me show you what I mean by that. So let me give you some folk statistics. And I don't want to argue about these because, you know, the details are full of devils. So 9 out of 10 visits to the doctor are at the wrong time. So they don't have the right information. It's too late, it's too early, you're just worried. There's a huge amount of inefficiency in that initial interface to the healthcare system. Interestingly, that number mirrors the sorts of numbers you hear about the effect of an aging population on the healthcare system, which is that you might get as much as a factor of 10 cost increase. Well, gee, if you could make all the visits at exactly the right time, maybe that would cancel out a good fraction of that demographic effect. And of course, there's the other folk statistic you hear, which is that 80% of the disease load is due to poor behavior. So the thinking for that for many years now has been that we need to build a much more proactive healthcare system. And that's where this word of the third ring comes. So for instance, the key sort of poster child here is the Costa Rican healthcare system, which I've been privileged to be a little minor part of, which has very standard organization, looks very much like the United States, has almost exactly the same outcomes on every single scale, and costs between a quarter and half as much as our system. And the only really substantial difference is that they have a third ring of health. And that third ring of health is nurse midwives who visit every human in the country at least once and generally several times a year to give them information, but perhaps more importantly, for triage, to get somebody into the hospital, into the clinic at the right time, asking the right questions with a little bit of data about how they actually live and why this condition might relate to what it is they've been doing. Well, in this country, we're unlikely to have that third ring be actual nurses that visit everybody. And so people talk about putting minute clinics in Walmarts, we were just talking about it, or pharmacies, and smart medical homes, and schools, and community centers. And together with my sister, we started this thing called the Center for Future Health at Strong Hospital at the University of Rochester to develop a lot of this technology. But there's some serious questions about it when you put on your business hat. One of the most serious is that for any of these new technologies, historically you find that only 10 to 15% of the population adopt these things. People just don't use them. They sit back and say, that's really nice. I'm going to open another beer. Okay? Get used to it. That's the way people are. And then the other side of it is, oh, well, this is going to cause better interfaces with the doctors, right, with the medical system. Well, what does your third-party payer think about that? Because what they're going to ask is this has to have a dramatic short-term return on investment. Otherwise, we're just not going to go for it. And unfortunately, most things are about better quality of care or long-term ROI. And I'm sorry, in today's environment, that's really uphill battle. So the conclusion that I draw from this is that if we're going to build this third ring of healthcare, if we're going to get that factor of 2, factor of 10 improvement that we see in some of these other healthcare systems, we have to use technology that's already deployed or technology that's deployed for some other reason where the cost stream is defrayed by these other uses of the technology. Well, that sounds like a dream, except that we already have it. So today, virtually everyone in this room carries a cell phone. Probably 40 to 50% of you carry smartphones that know where they are. They know about your web browsing. They know about your email. They know about your call pattern. Very soon, if not today, they know about your buying patterns. They have accelerometers. They know how you move. They have audio, obviously. And over the last couple of years, we've been using these to do a variety of things that you would consider healthcare. In fact, we just finished and are about to release an open source program that was paid for by Google Health, with a discussion being that if we did our work really well, and we think we have, this might be the front end for Google Health. Unfortunately, Google Health got turned off because of lack of subscribers, but the benefit is now it's open source and it'll be available to all of us. So it looks at all of those things I just said, but also your Facebook activity and browsing and your webs, and it can ask questions and things like that. So Qualcomm, Motorola, Samsung, Procter & Gamble, Best Buy, World Economic Forum also all helped develop this platform. There's the URL up there if you're interested. But now using this has an obvious problem. You say, well, look, you know, what does this have to do with healthcare and all those clinical measurements? And that's really a core issue, is that today health science, diagnostics, drug treatments are all built on a historical accident. Historical accident is in the 1800s. If you were wealthy, you would take a trip into the central city and you would say, Herr Dr. So-and-so, the famous doctor, and he would take blood samples or something like that. And around that tradition grew up health science that has matured into what we have today. But it's all on the sorts of measurements you can do in an office with supervision of trained medical personnel. On the other hand, there's another way to do healthcare, and you see it in our healthcare system, but it's not emphasized. So if you talk to a doctor, if you talk particularly to a psychiatrist, talk to a neurologist, and you sort of get them out for dinner, maybe a glass of wine, so you say, can you tell when something's wrong and somebody walks in your office before all those tests? And the answer is, yeah, I sort of can. Not only can I tell if something's wrong, I can sort of tell what is wrong. And the truth is, you can do that. You can do it pretty well. It's not perfect, but rigorous scientific tests have shown that humans can judge other humans with a little bit of training with very considerable accuracy. And then you see this in things like clinical global impressions. So that's a common scale used for triage in emergency rooms and other situations at admission. What it basically is, so, Mr. Doctor, Miss Nurse, sorry, gender stereotyping there, what are your impressions of this person? How did you read them? You write it down in this little form. So what is it that humans are reading about other humans that you can actually read a lot of what's wrong or what's right about a person? Particularly able to do triage, to be able to tell when something's wrong and what type of thing it might be. If you think about that question from an evolutionary point of view, it's sort of clear. If you're out there in the field, you know, a couple 100,000 years ago, and you're about to go attack that mammoth, you would like to know if the people at your back are healthy or not, right? Or if you're about to take the hike through the mountain pass with the whole tribe, you'd like to know that people aren't coming down with some sort of disease. You have to be able to read people in order to survive, and people can. And I've been studying this for the last 10, 15 years. There was an article in Nature recently, a 3-page article, which is extraordinarily unusual. Nature is the sort of leading scientific journal in the world, looking at what I've come up with, which is called honest signals. It's a biological term. It's a way that species, social species, are able to read the behavior of other social species. And you can use that to do a lot of things that you might find surprising. I'm going to tell you a little bit about that. But to understand of it, first I have to disabuse you of something that probably all of you have been trained in, which is that in the last 40, 50 years, if you learned anything about how people think, you were taught cognitive science. And cognitive science focuses on our mental representations and particularly our sort of linguistic processes, because that's the science that was developed, and it was developed in reaction to behaviorism. But if you look at the Nobel Prize documents, Danny Kahneman, or even Herb Simon, you see a very different model of human decision-making. And this is actually drawn from Danny Kahneman's Nobel Prize lecture. It says that people have two ways of thinking. One is the attentive, linguistic, serial, rule-based way that we're all familiar with and go to college for. So almost all health interventions are based on this. We give people information. We give them arguments. But the fact of the matter is that 95 to 98% of all behavior does not use that way of thinking. It uses a much older way of thinking, which I've labeled habitual here. Danny called it System 1, not quite as sexy. And it's fast, parallel, automatic, and associative. And it's not rule-based. What it's based is on your experiences and the things that you've seen other people do, really experienced stories. And it's your intuition about things. And almost all of our decisions day to day are made on that. Most doctor decisions are based on this, because we don't have the time to go through all those chains of logic in everyday life. And in fact, if you look at the lab experiments, this intuition is actually better at getting results than thinking things through for problems that are complex and involve a lot of trade-offs. It's hard to believe, because we have a lot of sort of, propaganda to the adverse, but in fact, people reliably perform perhaps 20% better when they're talking about using their intuition, except, of course, if you get out of your domain of expertise and experience, in which case you can do horribly bad, right? So thinking about this, what we ought to be doing is we ought to be thinking about reading people and thinking about their intuitive, habitual responses to things when we think about building interventions with people. So let me talk about the honest signals here and how that affects your intuition and your response and the way you think about it. And it's not logic, and it's not sequential, and it's not conscious. Okay? So you probably all accept that apes use signaling, dominant signals, sexual signals, etc., to be able to coordinate themselves. And you probably all accept that humans are evolved from apes. Then you probably need to accept that humans have signals too. and that they cause responses in us. And here are a few. So the first one there is actually a reading of your autonomic nervous system. So what happens when a 3-year-old becomes excited and interested in something? Well, they jump around and they talk, and you can't shut them up, right? They have higher levels of activity. It's nervous energy, right? We know this. What happens when a dog is excited or interested? Well, he barks and the tail wags, right? So what that means, if you think about it, is that means you can read the interest and excitement level of a distantly related species, a dog, without even thinking about it. Humans can read that level of, that sort of autonomic nervous system excitation. Or take attention. You probably haven't thought of this. How do you know when someone's paying attention? It is not the words. It has nothing, very little or almost nothing to do with the words. On the other hand, if they're anticipating what you're doing, if they're able to synchronize you with you very tightly, that's a different matter. It takes 400 to 600 milliseconds typically for things to enter your eyes and then get out in some sort of motor action. But yet when we talk, we're within milliseconds of each other in turn-taking. The only way that happens is if you're not only paying attention to someone, but you're modeling them very closely. And so you can measure the timing between people or between the person and a task, and you can measure their attention level in short sense by short sense. In fact, this is a clinical measurement for language development with preverbal infants. So if they respond to their mother in this very tight dance, this choreography, then probably things will be okay. But if they don't, then either there's a neural problem with the infant, or perhaps the mother has postpartum depression. And either way, there's likely to be language problems. A third thing that you see in humans and also in apes is mimicry. If we sit close together, and you actually have to be proximate to each other, and I nod my head, you'll start nodding your head, and you won't even be aware of it. If I smile, you'll tend to smile, et cetera, et cetera. And that mimicry is thought to be something that is a mechanism. It's a brain mechanism, a cortical mechanism that helps learning. We literally can read out other people's actions in our brain as it happens. That's a pretty amazing thing. In humans, it's highly correlated with trust. So if I want to do something, so let me give you an experiment that a friend of mine, Jeremy Bailenson, did at Stanford. He had a little computer avatar that wanted to convince people to follow a particular behavior. And so that they had the little script, and the guy did it, and you got a certain success rate. And then he snuck in a camera and watched the person, and the avatar, the computer avatar, moved its head the same way the person did, with a 4-second delay. So when you nodded, it would nod. Nobody noticed, but it was 20% more accurate, more effective at selling, and people rated it far more trustworthy. And in our data, when we look at people and see mimicry, the selling is sometimes up to 40% more persuasive and more effective. And a final one is consistency. Final one I'll talk about, there are more. These are the ones we typically measure. It's consistency. So consistency is fluid performance, fluid movement, as opposed to halting and irregular movement. So the halting and irregularity is an indication of cognitive load. You're conflicted, you're confused, you don't know what to do. And what that shows up in behavior is as irregularity. When somebody's very fluid at producing something, they've practiced a lot, and the impression of expertise is much higher. So what does this unconscious signaling do for people? Well, it's a way of reading out brain state. It's like fMRI, but larger systems. And it takes a little longer. You can't do this on a second-by-second basis. It's a 30-second, maybe a minute. It's like our social sense. So let me give you some examples. And these are actually in commercial trials at the moment. Several hundred to several thousand people. So for instance, a healthcare provider calls up somebody with congestive heart failure and says, you should enroll in this exercise program. And what does the person who's in the clinical trial that has congestive heart failure say? Well, they say, well, sure, I'll do that. Except that only about half of them actually do. But if you listen to the signaling, you can tell which ones will do it and which ones won't. And if if the voice says, yes, I'll do it, and the signaling says no, then you know you can spend more time on them, and have to spend more time to get them to actually go. Or here's a really big one, screening for depression. Depression is the #1 cause of lost days of work. It's arguably the largest disease load in humanity. And part of that is not that depressed people kill themselves, although they do, they don't take care of themselves. That's the other aspect of it. And in a population like congestive heart failure or diabetes, typically you have prevalences of 30 to 40% depression, but typically only 2 or 3% are diagnosed. And the rest cost a lot more money and don't get well. And so what we've developed is computer tools that listen to the interactions, no questions, just listening to how they say things, and able to do comparable to gold standards, just listening to the pattern of conversation, regardless of accent, even regardless of language to some degree. Pretty interesting. And this works for a variety of other things. We've done dating. You can tell if the woman will say yes. We've done job negotiation, a variety of things that you might be interested in. I'll pitch my book here. You're supposed to buy the book, right? Okay, sorry. So I've talked about reinventing clinical signals. Now let's talk about what else you can do. So folk wisdom is that 80% of behavior, of health problems, of disease burden, is due to behavior. Not being compliant, doing things you shouldn't. And remember this brain model that Nobel Prizes winner Danny Kahneman and Herb Simon put forward. So what we have to do is somehow think about this habitual brain and not the conscious brain when we think about these things. And we've done experiments like this where we give people, say, for instance, cell phones for a year, everybody in a community. And what we find is that things like eating patterns, health patterns, weight gain, even political views, are acquired by contagion from people like you that are around you. When in Rome, you do what the Romans do. So the interesting thing is that it's exposure and not conversations. So there's been a lot of news about, oh, your friends make you fat and your friends do this. Turns out, in this data at least, it's not your friends at all. It's not the people you talk to about your problems that change your behavior. It's the people you hang out with. If everybody takes a third slice of pizza, you'll take the third slice of pizza. And this accounts for 75 to 85% of the variance in predicting who will gain weight, who will stop eating salads, and so on and so forth. That's a little bit of a cheat because 50% of the variance is accounted for by saying nothing changes. But still, we get 25 to 35% of the variance by looking at the people around you. So this has major implications. Here's people moving around in San Francisco. Looks like a nice place. The black dots are the popular bars and restaurants and shows and stores. Looks like a nicely mixed city, but if you analyze this, you find that there are subgroups, tribes, that spend all their time with each other and not with anybody else. And if you think about that, you know, there's the young hipsters that do something, there's the, quiet, sedate family guys that do a very different thing. And you can break this population into different groups. And it turns out these different groups that spend time together learn from each other through this contagion process I just talked about. And so the green guys have different behavior than the blue guys in terms of what they buy, in terms of whether they pay back loans, in terms of their political views, and in terms of their health. Some groups have very high prevalence of HIV, some have very high prevalence of diabetes, some have very high prevalence of alcoholism. The typical lift over normal demographics is a factor of 5 to 10, so it's a huge effect. And all of this is without knowing who the people are. You're just looking at their pattern of behavior. So the way to think about this is demographics, where you lived, used to predict a lot about you, doesn't anymore. But now, what predicts a lot about you is your behavioral demographics. Where do you go? Who do you spend time with? What do they do? Once I know that, I know a huge amount about you. have to watch the time here. So what can you do with all this stuff? Let's see if we can get the computer to pay attention to us. Well, let's go one step further. I've shown you things like weight gain and eating behavior, which is largely unconscious. We don't think it through every time we do it. We just, oh, I really have to have another slice of pizza. What about conscious decisions? Well, we've done the same sort of experiment where we gave out phones to everybody, and we looked at things like, who spent time together, who they called, who were their friends on Facebook or on their contact list, et cetera, et cetera. And what we found is just like the exposure model for weight gain and so forth, even for conscious decisions, like what piece of software are you going to buy, we can do a really good job at predicting what you're going to do next. That's pretty surprising. People are very predictable. But if we know the people around you, and we know these different types of networks, then we can combine those networks to be able to predict what it is that you're going to do next as a function of the people you talk to, spend time with, interact with on Facebook, and so forth. So for conscious decisions, it's many networks that matter. Interestingly, you see, a random prediction is not very good so random means if you use all the statistics in the population, you can't be very good at predicting what people will do next. If you use who their friends are, that's the GA, you're about random. It's not your friends. On the other hand, if you look at the people you call, the people you spend time with, et cetera, you can do a really good job. Okay? So what can you do with this? Well, one of the things you can do is you can use the phone and all those networks that go through the phone as a sensor for quality of life. A general sorts of thing. Are your patterns that are healthy? Are your patterns changing from healthy to unhealthy? So this is good for population management. Imagine that you run an elder care facility or a university. You'd like to know where things are going south and where things are healthy. And if you have some sense of what's going wrong, then you know how to begin targeting interventions. You know how to manage your population better. And we have a spin-off in this area too called Ginger.io. It's just got its first round of funding. So you're referred to them if you want. And of course, the final thing that you want to be able to do is you want to be able to shape behavior. How much time do I have? Okay, because my watch is apparently not, still on Italian time. Okay. So I've said you can look at specific diseases like depression, specific behaviors. I've said you can look at behaviors in sort of learned behaviors. You can look at, predict what people are going to do, and actually do some population assessment. What you'd like to be able to do then is shape behaviors to have people have more healthy behaviors. And again, to go back to Danny Kahneman's model, you don't want to give them arguments. You don't want to give them facts. It's not going to work. You all sort of know that, but you do it anyhow. We all do. What you want to do is something else. And let me show you something else that we did, recognizing that it's these social ties, the exposure to other people, that is the potent force in behavior change. We said, well, gee, why don't we leverage that rather than fight it? And this is what we did. We took a population and we broke it into 3 groups. And in one group, we gave you a reward, a monetary reward, if you became more active. That's a good thing, right? And in another group, we gave you a reward if you became more active and you got to see what your buddies were doing too. So you had that social component, right? Those are the 2 big popular things that people do. And we didn't do that in the 3rd group. What we did in the 3rd group is we gave the reward to your buddies if you became more active. So what does that mean? Well, that means that when you show up in the audience, in the workplace, the guy in the next office is going to say, so, you've been more active recently, right? When you go to lunch, the guy you sit down with says, How you doing on that activity level, huh? Because they have a little bit of a reward in there, right? So it becomes a topic of conversation. These are not large rewards, they're small rewards, but it's enough to surface this as a topic of conversation. And the interesting thing was, when we looked at the efficiency of behavior change in these three groups, this social leverage group was twice as dollar efficient as the other groups. Twice, times two, okay? And the effect increased over time rather than decreased, which is a good sign. Now, we don't know if it's stuck forever, but it's interesting to see that this way of thinking has ways of actually moving forward to causing things happen. So all of this depends on having an infrastructure where I can see all of your behavior, or somebody can see it. And that has obvious problems for privacy, because these aren't clinical measurements. They're not under HIPAA. So what are you going to do? Well, for the last 4 years, I've been starting a project with the World Economic Forum, and for the last 2 years, we've had fairly regular and intensive meetings with the chairman of the Federal Trade Commission, the EU Director of Commerce, the UK Director of Commerce, people represented from the White House, the CEOs and chief legal counsels from Microsoft and Google and Cisco and Qualcomm and Verizon and AT&T and MasterCharge and Equifax and the ACLU and OpenID and many of the large insurance companies who don't want their names listed. And then there's people like us, MIT, and Harvard, my buddies up the river. And we've come up with a new way of thinking about this data that everybody seems to agree on, which is an amazing thing by itself. And it's actually not that different from what you see in pure medical records, which is that there has to be a change in the way this sort of data is handled, where you, the consumer, controls the data. It's your data. Now, companies have to have a little bit of that data in order to operate, but the fundamental principle is that you, the consumer, has to have that data and control over it. And why are the companies willing to go along with that? Because if you have that data in the cloud someplace, then they can make you offers to use that data. They can say, if you show me this bit of your data, we'll pay you $10 a month, or something like that. So for instance, if you were a drug company, you could say, anybody who wants to, you get $10, but tell me about your experiences or show me your activity levels after you took our drug. Wouldn't that be an interesting change in the way you did statistics for side effects and after effects or treatment therapy? So it opens up a new asset class. It makes the data liquid in a way that it isn't today. Today, when you think about doing these things, oh, but I have to have this big clinical trial, and I have to recruit all these people, and it's horribly expensive. Imagine that you could get that data in a morning. You might have to have a sizable budget, but you could get data from, say, 1 million people in a few keystrokes and a sizable wallet, right? Or a way of offering them services that they wanted. What would that do to medical science? What would that do to health, population health? If you could really look at all the things I've just been talking about with specific objectives and specific controls in place, it would transform those sorts of science. And so, under sponsorship of many of these companies, we've begun a open source project to build this, along with our open source sensing project platform. If you look at ID Cubed, you'll see the initial website. And the idea is to have a concrete realization of the sorts of standards that the National Cyber Identity Initiative is proposing and the World Economic Forum meetings have been indicating is acceptable worldwide. And that's it. For more information, see our website. Thanks to all the guys that work with me. There's a lot of them. And I'll take questions. Thanks. You could come up here. It's off.
Yeah, okay, it's better. Okay. Well, thank you, Dr. Pentland, for a very nice and thought-provoking talk. I think it's been great. I think we should all watch out our friends and make sure that we hang out with the right people. We have time for a few questions. Yes? Actually, going to pass on the microphone.
So thank you for a very inspiring talk. I have attended another one of your talks at ICPR 2004, and that was equally very inspiring. My question is about the fact that you are talking about connections with peers, but I think the hierarchical connections matter a lot. So whether you have a boss that you don't get along with, that can make you overeat, that can make you drink more. The infrastructure is also, like, the company that you work for is also very important for your health. Like, whether you work for a corporation or a university or the government or you have your own company, the stress patterns are different and they will affect your health.
So stress factors are clearly a major thing. It would also be noise level or, you know, family health problems. All of those can cause problems. And I'm not going to deny that your hierarchical, your position in the network is a source of much stress and other things. But what we find when we look at the data, and these are unique data because people have never measured these things the way we've measured, which are 24/7, quantitative, over reasonably large populations, we find that the peer-to-peer effects dominate. And not dominate but a little bit, they dominate much more. And so what I think is going on is that our conscious awareness is of these point features, the boss, the job, the whatever. But in fact, the background stress that comes from all of our peers, or the background support that comes from all of our peers, often it seems to be the larger effect.
Other questions? Yep.
Thank you very much for the very interesting talk. Maybe it's a weight question, but there is any genetic impact? Like, do you think there is, when you hang with certain people, these people can have, they can change you genetically, or there is any, according to that desert gaps, do you think, I'm not sure.
So there's two processes that go on. So when you hang out with people, you have this implicit learning of lots of different behaviors, and of course adoption of, for instance, the stresses and other things that they have. But there's also a selection process of whether you identify with them and join and spend time with them. So there's both an assortative mixing and the Samophily effect at the same time. Nicholas Christakis has some really interesting data showing that who you spend time with has a lot to do with your genetic makeup, who you're friends with, et cetera, which is in some ways not too surprising. We know that you know, birds with a feather in many cases do hang together, fly together. Not always, but there seem to be some sizable effects there. I've never seen anything about changing your genetic structure as a function of things like this, although there's some interesting stuff in science and nature about, you know, viruses mutating, you know, or passing between generations and so forth.
Other questions? Yep.
Thank you very much for an interesting talk. It seems like most of the data collection you're doing has to do with who you're physically in proximity with or who you're in communication with. But it seems like there's a whole other level of data to analyze, which is what kinds of data that you're consuming on your smartphone, which websites you visit, you know, how many text messages you use, that sort of thing. Is that another avenue for kind of developing a next level?
Yeah, absolutely. I mean,
this?
you know, part of what we do is an argument with society. The typical thing people do is they look at, you know, web data or linguistic statements or things of that sort. That's a common thing that people do. So we don't have to convince people to look at that data. What we have to convince people to do is to look at behavioral data that's independent of the linguistics stuff. That said, so we tend to emphasize the non-linguistic behavioral aspects, There's two reasons for that. One is, as I said, there's a sort of making your point reason. There's a privacy thing too, which people tend not to mind watching behavior as much as they mind watching words. So like in typical day-to-day things, if we record words, people are very picky about that. If we don't record words or very specific things about the interaction, people are much more comfortable with that from a privacy point of view. So we tend to go in that direction. The other thing I will say, though, is that in our data, the non-linguistic effects, the behavioral effects, are typically larger or as large as the word choice or statement-making sorts of things. So it's these, don't listen to what they say, look at what they do, seems to have at least some element of truth in it. It's obviously a huge issue, and I can't address the whole thing. But I would say is, the behavioral stuff is bigger than you think.
Okay, we have time for one last question. Yes, over there.
Thank you for your talk. How can we apply what you've learned to people who don't have large social networks? For instance, you mentioned people with depression, where a common symptom is to pull back from friends and neighbors.
So if you look at DSM-4, so the mental health diagnostic, right, almost all of the serious mental illnesses have elements of reduced sociability and reduced activity, reduced initiative. And even if you don't call anybody, if you carry around a cell phone, I can see that you haven't left the house in 3 days. I can see that you've got perseverative behaviors in some cases. There's many things I can see. Another way to look at this, though, is there's not a specific diagnostic thing. So we can do some of that specific diagnostic. But there's another thing which is sort of a general sense of the quality of life that the person is enjoying. And if you see big changes in socialization, big changes in activity, etc., then you know something has happened to them. It may be nothing. It may be a great thing. But it might be worth a call and asking a question. And, if you think about that, the right question at the right time is infinitely valuable. And so it gives you that sort of insight at the very least. If somebody is already severely depressed, it may be a different thing. I will mention we did an inpatient trial in a local hospital where we compared physiology. So we looked at, heart rate variability, GSR, all those sorts of things, versus the signals. And we could do a better job at predicting depression levels. These are for profoundly depressed people than you could with the physiology, which is pretty interesting. Just a little bit better, but still, it seemed to say that behavioral measures are actually competent to do a surprisingly good job.
Okay, thank you, Dr. Pentland, and I'd like to invite you to give another round of applause.